In today's video, we will be discussing Physics 251, Week 9, Video Explainer Problem 53. In this problem, we will be relating work, gravity, mass, and distance, as well as finding out how the mass of a planet affects a comet traveling towards the sun. This problem is one that we saw in our Mastering Physics for this week, and a lot of the equations that I use throughout this problem are found in our Week 9 lecture notes. So to start off this problem, I've gone ahead and underlined a few constants that I think are helpful to note, such as this assumption right here, which I think is important, and some of these constants for our comet and our gravitation. So I've gone ahead and looked up some of the constants that we will be working with, such as the mass of the sun, the distance from Mars to the sun, and the distance from Mercury to the sun, all of which I found on Wolfram Alpha. So as far as starting this problem, what we're going to do is we're going to be using this relationship here for work, force, and distance. From here, we're going to plug in our equation for force up here, and from here, since we're assuming that x2 is smaller, we have our integral relationship for x2 and x1. When we evaluate this integral, we get this right here, at which point we can solve for the two x's, or I guess evaluate for the two x's, and we get this relationship right here. So this relationship is going to help us in the next problem, or in the next section of the problem, because we can relate the work to our kinetic energy. And if we remember, this is the relationship that we are looking at, and of course kinetic energy is equal to this right here. So here I have work equal to the two kinetic energies with final velocity and initial velocity, and from here we can kind of name some of our constants that we're going to be working with, just so they're consistent throughout the problem. Here I have our Mars to the Sun distance and Mercury to Sun distance, and the reason that I chose these is because we are still assuming that x sub 2 is less than x sub 1. So when we plug, solve this equation, we can pretty much, this is m1 right here, so what we can do is we can cancel the m1s with the m1s over here, and we're left with this right here. And from here, we can plug in all of our variables for gravitation, mass, and distance, and we get this value here in meters per second. And from here we can just solve for the final velocity. From my calculations, I got that the final velocity was 6.36 times 10 to the 4 meters per second. So this is the amount of, or this is the speed of the comet as it reaches this, as it reaches Mercury's orbit over here. And you can see in our image kind of what we're looking at in the problem. Here's our comet. And yeah, I hope you guys found this video helpful. Thank you for watching.